Okay, we have matrix B, and we're given that it has 3 eigenvectors, 1, 2, 3, and the corresponding eigenvectors are 1, 0, 0, 2, 1, minus 1, and 1, 1, 0. We want to find b to the 6. So we start off with BP equals PD. Okay, we talked about that in the last video. So P is made up of the eigenvectors. It's just a matrix made up of the eigenvectors. And D, the diagonal of the matrix, are made up of the eigenvalues. Okay, so this is P. Okay, this is the P, and it's made up of the eigenvectors. So the first eigenvector 1, 0, 0 is the first column. The second eigenvector is the second column, and the third eigenvector is the third column. And D, this is D, and the diagonals are made up of the 3 eigenvalues. It must be in the same order. Okay, 1, 2, 3, you can't swap the order. Okay, the next thing to do is make B the subject. Okay, so we're going to multiply both sides by P to the inverse P. Okay, so we end up with B equals P D inverse P. Next thing is put both sides to the power of 6. So B to the 6 will equal P D to the 6 P to the minus 1. Now, just remind you that PD B to the minus 1 all to the power of 6 equals this, and the inverse P's all cancel out. That's why the only change is to the D. Okay, so we need to multiply 3 vectors together, sorry, 3 matrices together. So we've got P, D to the 6, well, we've got D. D to the 6 is straightforward because the only non-zeros are the leading diagonals. The only difficult bit is inverse P, which we don't have. So that's going to be most of the work. We need to work out the inverse of P. Okay, so we need to work out the inverse of P. Okay, there's P. We want to find inverse P, so we use augmented matrix. So there's the identity matrix. So we want to manipulate the rows so that this will become that. Okay, so we want these 3 to be zeros and these 3 to be zeros. Okay, so the first thing I'm going to do is make this a 0. We want this to be 0, so we're going to add these 2 rows, the entire 2 rows, and this will become a 0. Okay. So we've got these 3 zeros, now we need these 3 zeros. Well, to make this a 0, we just need to subtract these 2. Okay, so we're going to do row 2 minus row 1. Okay, we want this 0 next, so we got these 2 both 0. So we're going to do row 3 minus row 2. Next, we're going to do row 2 minus row 1, and then this will be a 0. And now we've got everything is 0 apart from our leading diagonals. And it's the last easy bit to make these all positive 1. This middle row needs changing. We need to multiply everything by minus 1. Okay, and that's our inverse. Okay, back to our equation. We know P, we know D, we don't know D to the 6th, and we know inverse P. Okay, there's our P, there's our D, we need to raise it to the power of 6, and there's our inverse P. And you might sort of think we've still got to raise this to the 6th, but this is an easy one because it's only got a leading diagonal. And let's do that first. So b to the 6 is 1, 2, 1, 0, 1, 1, 0, minus 1, 0. Now raising this to the power of 6 is easy because when you multiply that row by that column, the only thing you do is you're doing the 1 times 1, and you've got to do that 6 times. And when you do the second column, so second row by second column, you're just going to be multiplying by the 2 by itself 6 times, and then the 3 you'll multiply by itself 6 times. So 1 to the power of 6 is 1, and 2 to the power of 6, 2, 4, 8, 16, 32, 64. And 3 to the power of 6, 3 to the power of 6 is 729. And again, we're going to multiply that by 1, minus 1, 1, 0, 0, minus 1, 0, 1, 1. So all it leaves to do is to multiply 3 matrices together. So you can either do that one times that one, and the result you times by that, or you could multiply these two first, and then multiply this by the result of those two, but you must do it in that order. Okay, you can't multiply that one by that one and multiply the result by that. Okay, and once you've done that, you get this as your result. Check it with a calculator.